Hey, I want to briefly cover the idea of friction. Friction kind of comes in two kind of big categories. One is what's called static friction, when things are not moving. And the other is kinetic or sliding friction, when things are moving. It may seem interesting that kinetic friction may be more likely the one that's going to be easier to understand. Let's say I'm pushing a box or dragging a box and it's sliding, and I have a certain amount of force or friction between these objects. I may have a frictional force opposing the motion. The friction would end up going that way, tension to the right, and that friction would have some value. Say it's 10 newtons. Now what seems interesting is that as long as I'm sliding, no matter how fast I'm going, that frictional force is still 10 newtons. And so friction is dependent on two different things. One is, the roughness of the surfaces. And the other one is how tightly they're pushed together. A smooth surface, say like ice or polished steel, will have less friction than something like wood would have a lot of friction. Ice and steel may have a little bit of friction. The other one is how much they're pushed together. A lot of times we think of this as the weight, but not necessarily. I could push two objects together or even lift them, and that would end up changing the amount of friction I have between the two. But the important thing in kinetic friction is once we start moving, then the amount of friction stays the same, whether we're moving fast or slow. Now, the interesting thing with static friction, or when things are not moving, is that it can increase or decrease in response to a force being applied up to, increase or decrease, up to some maximum, to a maximum. And you'll experience that if you're trying to push something. Push a little bit, it doesn't move. Push even more, it doesn't move. Finally, I break it free. What you've done is you've got greater than some maximum value. Let's take a little look at this. Hey, let's say I'm pushing at 15 newtons on this box here. It isn't moving. It must be because the frictional force is 15 newtons. I push a little bit harder. Now I'm going to push with, say, 20 newtons. It doesn't move, so I know that frictional force is 20 newtons. I'm going to push even more. I'm going to go to 25 newtons on this thing. 25 newtons. If it's not moving, I know that forces are balanced, so it must be 25 newtons of friction. Finally, say I break it free, and that's the maximum static friction. I have to push more, let's say more than 25 newtons. Now I'm pushing with 30 newtons of force. That's exceeding the maximum 25 newtons of static friction I can have. And what do I find? These are unbalanced forces. My box now begins to move, or accelerate is probably the better way of saying. Then what forces are there, it'll just be a matter of what that static friction is. Once we start moving something, in your own experience, you probably find this as well, is that it actually gets a little bit easier to push something. And so another kind of a rule of thumb is that the maximum amount for static friction is typically greater than what the kinetic friction is. Maybe, for example, this may start, once we start sliding, there may only be 20 newtons of force resisting that. What I can do then to push this box at a constant velocity is then back off a little bit. I'm pushing at 20 newtons, and I would find that my box continues to move at a, that's right, balanced forces if it's already moving, constant velocity. Okay, a quick little note on friction.